Aloha and welcome to Hawaii Volcanoes National Park. I'm Ranger John here at the summit of Kilauea volcano with another eruption update. It's been an exciting season for us here in the park. A lot of changes, some of which have been really dramatic. And our geologists have been really busy up here monitoring not one but two independent eruptions. So right behind me here you can see the white plume of gases that continues to issue from Halemaumau crater. The vent out there is the product of a series of explosive eruptions, the first of which was on March 19th of this year. To date, we've had about 6 separate explosive eruptions, several of which have thrown liquid lava spatter hundreds of feet up and out of that crater. And some of those explosions have also significantly widened the vent, collapsing the rim of it. So through explosions and also by more subtle, gradual collapses, that vent has continued to get wider and wider. As you're seeing it today, it's more than double the width it was at the beginning of the summer. So even though it doesn't look like it, that vent out there is about 2/3 the length of a football field. Right now it's approximately 215 feet wide, and it'll most likely continue to collapse. So it's a pretty exciting process. So the volcanic gas emissions from this vent are high, but they change a lot, they fluctuate. Right now we're relatively high. That vent is producing about 1,100 metric tons of sulfur dioxide in a day. And that's pretty high considering that before the vent opened, the crater was releasing about 140 tons a day. But it continues to change. Well, these gas emissions are also kind of linked to episodic tremors we have within the vent. So there's a whole lot of seismic activity here, some of which have been these rhythmic episodic tremors. Now, geologists have been describing for some time now what they call a gas pistoning event. The data has been telling them that inside of that vent there's a pond of lava, and occasionally that pond will crust over the top as the surface cools and the gases are trapped beneath that crust. Eventually the gas pressure beneath the crust will lift the lake and break the crust, and we see the gases again. So that gives us a kind of constant fluctuation up here. But some of those pistoning events have caused kind of mild explosions, I guess you can say mild explosions, that initiate ash ejections, and that whole plume will turn dirty gray or brown with ash for a few minutes at a time. And that, of course, is always very exciting. But it wasn't until this month, September 5th, when we first had our first flyover of the vent, and we're finally able to see down inside of it. And just as I suspected, there is in fact a huge lake of lava in there, boiling and churning away, releasing all those gases. So this new lava lake in the vent at the summit crater has been pretty exciting, but it continues down the East Rift, which runs off the caldera this direction. The vent, volcanic vent Pu'uo'o, continues to produce an extreme amount of gas. It rises and falls much like the summit vents. But the vent down there has been through a lot of changes over the summer. We continue to have these sequences of events that geologists call deflation-inflation events, or DI events. During these events, they begin with deflation, as the summit and the East Rift zone typically deflate. And then after the deflation event, they inflate again as the magma fills chambers underneath the mountain. Now, most of these inflation-deflation events have been correlated between the two eruptions. First, the summit will deflate, and within a few hours, the East Rift will deflate. And then as the summit inflates, the East Rift will track it a few hours later. Currently, we've had a little bit of break from the norm. The summit deflated and inflated, but the East Rift waited for over 22 hours before it began its inflation event. That's somewhat conspicuous to us. And these inflation-deflation events have also caused a few eruptive pauses in the East Rift over the summer. The pauses are where the lava stops flowing through the tubes to the ocean. We either have reduced flow or ceased flow temporarily. And right now, there is no lava making it into the ocean. Finally, the vent down there has begun inflating, and our thermal imagery from the satellites indicates that the lava might be working its way down to the coast as we speak. But this is kind of a conspicuous event, since that tracking of the inflation-deflation has kind of left the normal pattern, And we've also seen a little bit of extra inflation during that process up here at the summit. So it's likely that that lava lake in the summit is much closer to the surface right now, and that gives us elevated gases and a much stronger glow in the evening. At this point, geologists aren't really willing to commit to any guesses about what might happen next at Kilauea, but I'm a ranger, so I can give you a few scenarios. You see, both of these two eruptions we've been watching are fed by the same summit magma chamber within the mountain here. And if anything significant changes within the mountain, say if something were to block the conduit that feeds the eruption in the rift zone, then the most likely place to see the lava come out would be here at the summit vent. And that would be very exciting. So if something changed and the eruption in the rift ceased, it's entirely possible for us to see lava fountaining out of the Halima'uma'u vents, or the level of the lake inside could simply rise and spill out onto or even consume the floor of the crater. That would be very, very exciting. Even as I speak, the vent has been somewhat noisy, making booming, rock clatter, and thundering sounds, which is enough to keep us all interested. And one thing's for certain, everybody up here is very eager to be here to witness whatever happens next.